Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math Grade 8, Unit 8, Lesson 3. Our first question on here is find a positive solution to each equation. If x squared is 36, what does x have to be? The square root of 36 is 6. If x squared is 9/4, what does x have to equal? For this one, it has to be 3/2. Square root of 9 is 3, square root of 4 is 2. For this one, it will have to be 1/2. The square root of 1 is 1, the square root of 4 is 2. If x squared equals 49/25, x will have to equal 7/5. The square root of 49 is 7. The square root of 25 is 5. Okay, next question here. 3 squares. Draw 3 squares of different sizes with vertices aligned to the vertices of the grid. So we have 3 grids here we can use. First, I will draw the obvious full square. What is the area of this? Well, the area of this is 1, 2, 3, 4. There are 4 full squares. 4 square units is the area. What is the side length of this? The side length is 1, 2. 2 units. Okay, now we need another square. The side length of this is 1 unit. Each of those 4 sides is 1 unit. The area is 1 unit squared. 1 times 1 is 1. Now, what are we going to do about this next one? That was an easy square to find. That was an easy square to find. And we are supposed to use vertices aligned to the vertices of the grid. Well, from here, all I can get is that square or that square. This one's a little tricky. This square is not going to be oriented the same as the other two. There's another square with vertices aligned with vertices of the grid. Well, what is the area of this square? Well, we're using up half of this 1 unit square, half of this 1 unit square, half of this 1 unit square, and half of this 1 unit square. So we have half of 4 squares. Half of 4 is 2, so our area of this is 2 square units. What is our side length going to be? Well, it's 1 square diagonal. It's the diagonal length of a 1 unit square but what is its actual length? Well, to find the side length of a square if we know its area, we take the square root. So the side length is the square root of 2 units. Area of 2 units, side length, square root of 2 units. So for each square we labeled its area, we labeled its side length. Write an equation that shows the relationship between side length and area. So we could say the area is equal to the side length squared. 1 squared is 1, 2 squared is 4, the square root of 2 squared is 2. Or we could look at this the other way and say the side length is equal to the square root of the area. So that's 2 different ways we can write an equation showing the relationship between side length and area. Our next question is, are any of these numbers a solution to the equation x squared equals 2? Is 1 squared 2? 1 times 1? No. One half times itself, half of a half is a fourth. That's not 2. 3 over 2. 3 over 2 squared would be 9 fourths. Is 9 fourths equal to 2? No. 7 fifths. Well, 7 squared is 49. 5 squared is 25. 50 25ths is 2. 49 25ths, it's close to 2. But that's still not 2. Looking for the square root of 2. A rational number is a fraction or its opposite, or any number equivalent to a fraction or its opposite. So, a rational number is a number that can be written as a fraction So 1/2 is a rational number. 2 is a rational number because you can write 2 as a fraction. 2 over 1 is equal to 2. Any number equivalent to a fraction or its opposite. So, find some rational numbers that are close to the square root of 2. Well, the 7 fifths we had before was 7 fifths squared was 49 over 50. 49 over 50 is very close to the square root of 2. Could you find another rational number, another number that can be written as a fraction, that is close to the square root of 2? I will leave it up to you to try and find another. Can you find a rational number that is exactly the square root of 2? That is our big question of the day. to answer that, I am going to jump down to our summary. The square root of 25 is an example of a rational number. A rational number is a fraction or its opposite. Remember that a fraction, a over b, is a point on the number line found by dividing the segment from 0 to 1 into b equal intervals and going a of those intervals to the right of 0. We can always write a fraction in the form a over b, where a and b are whole numbers, and b is not 0. But there are other ways to write them. For example, we can write the square root of 25 as 5 over 1. Square root of 25 is equal to 5 over 1. You first learned about fractions in earlier grades, and at that time you probably didn't know about negative numbers. Rational numbers are fractions, but they can be positive or negative. So negative 5 is also a rational number. Because fractions and ratios are closely related ideas, fractions and their opposite are called rational numbers because of the ratio in rational. Here are some examples of rational numbers: 7/4, 0, 6/3, 2/10, -1/3, -5, the square root of 9, negative the square root of 16 over the square root of 100. Those are all rational numbers. They're all numbers that can be written as a fraction. Can you see why they are all examples of a fraction or its opposite? That's a fraction. 0 over 1 is a fraction. 6 over 3. 0.2 would be 2 over 10. Those are all numbers we can write as a fraction. An irrational number is a number that is not rational. That is, it is a number that is not a fraction or its opposite. The square root of 2 is an example of an irrational number. It has a location on the number line, and its location can be approximated by rational numbers. It's a tiny bit to the right of 7 over 5. But the square root of 2 cannot be found on a number line by dividing the segment 0, or the segment from 0 to 1, into b equal parts and going a of those parts away from 0, if a and b are whole numbers. So the important thing to remember, and something we're going to be dealing with a lot more as we progress in this unit, is rational numbers and irrational numbers. The square root of 2 is an irrational number. It is not a number we can write as a fraction. So when we are working with the square root of 2, this is one of those nice times where your math teacher is going to encourage you to be lazy. And if you want to find a number that says a rational number, can you find a rational number that is exactly the square root of 2? No. Exactly the square root of 2 is the square root of 2. Don't put that into a calculator. If you put that into a calculator, it's going to give you 1 point, yada, 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 yada. A whole bunch of decimals. Those are not exact. The exact value of the square root of 2 and what you will be expected to write is the square root of 2. That is the exact value of the square root of 2. The "Are you ready for more?" questions on today's assignment, I'm not going to walk you through step by step, but these are something I would like you to try on your calculator. If you have at home just a regular plain 4-function add, subtract, multiply, divide cheap little calculator, try plugging this in. (577 over 408 squared). A lot of old calculators will give you a value of 2 for that. Why might you be suspicious of that result? Find an explanation for why 408 squared times 2 could not possibly equal 577 squared. How does this show that 577 over 408 squared could not possibly equal 2? Well, if we square the bottom and square the top of this fraction, for this to be equal to 2, the bottom squared would have to be half of the top squared, because for this to be a fraction, it would have to be equal to 2 over 1. Repeat these questions for this value. This is large enough that many modern calculators and computers will get wrong. Try this using your cell phone calculator. Try this using a TI calculator. Try this using the calculator built in to your Chromebook. Let me know what you get with these and leave your answers in the comments. Okay, this has been another episode of Mr. Boskin Does Some Math. Thank you very much for tuning in, and I will see you next time.